In a Harris poll of 514 human resource professionals, 45.9% say that body piercings and tattoos were big grooming red flags. Use a zero point zero 0.01 significance level to test the claim that less than half of all human resource professionals say that body piercings are big grooming red flags. Assuming we already did the first step of the hypothesis test and determined that the null hypothesis is p equals 1/2, the alternative hypothesis is p less than 1/2, and also we did the second step when we found the test statistic z equals negative 1.859. This is the left tail one side test with the z test statistics negative 1.859. In this particular problem, we only need to compute the p-value. Again, since this is the left tail test, we would indicate the z-test statistic and we would shade it on the left because the alternative hypothesis indicate that this is the left tail test. The area or the probability on the left hand side of the z-test statistic negative 1.859 is called the p-value. And so if we were to use the table, the z table, or a calculator, we will find that the probability that z is less than negative 1.859 is 0.0315. Remember that this is the z-score, so to find the corresponding probability, we would need to use the standard normal distribution. If we use StatCrunch calculator, then we would need to indicate that the mean is 0, the standard deviation is 1, with the z-score of negative 1.859, and we're looking for the area on the left-hand side. If we use StatCrunch normal calculator, this is the standard normal calculator with the mean of 0 and the standard deviation of 1. And since we have the z-score, we would use the mean 0 and the standard deviation 1. Again, always draw the bell-shaped curve when working with the normal distribution. From the curve, we see that there is no left endpoint, so the left endpoint is negative infinity, and the right endpoint is negative 1.859, and we have 0.0315 for the probability. And this probability is our p-value. If we were to use a table, recall that in the table, the z-values or the z-score are rounded to 2 decimal places, and so we would have to use z equals negative 1.86, where we rounded negative 1.859 to negative 1.86, and we proceed with the table. And with the table, the value is slightly different. Again, with the z table, we will see that the corresponding p-value or the probability on the left-hand side of the z-score will be 0.0314. The reason why we get just a difference p-value using technology versus using the table is because with technology, the values is more accurate. But what is this p-value? The p-value is the probability that we obtain the data at extreme as the one we observed, assuming that the null hypothesis is true. Recall that when we compute these test statistics z, we had to use the assumed null values 1/2. And once we obtain the test statistic, we can use it to compute the corresponding p-value. The smaller the p-value, the further away the test statistic, the further away it is from the center, the further away it is from the norm. This means the smaller the p-value, the more significance the test is. And so with the small p-value, we would say that the test is statistically significant. But how do we determine whether the p-value is small? And that is when we compare this p-value to the significance level alpha. And the significance level alpha in this case is 0.01. So compare this p-value to this alpha. Is it small? The answer is no, because 0.03 is more than 0.01.